I'm Chris Chinchilla. Welcome to my podcast, an enthusiastic ramble through whatever has taken my interest the past week or so. Expect technology, games, history, travel, geekery, and as always, much, much more. Welcome to another Chinchilla Squeaks with me, Chris Chinchilla. This episode is an interview episode, and it's a return visitor, a return guest. I guess that's a better word, yes. It is Venkat from Rockset. I last spoke with Venkat 2.5 years ago, so we did a little bit of catch up about what the company has been up to, what the product has been up to, their recent developments, and their plans for the future. Now, I have been using a new platform the past few months for recording many of my interviews, and I'm still finding a few weird issues with it every now and then, and there was one on this recording. For some reason, I don't know if Venkat wasn't using headphones, but I'm pretty sure he was, or I have no idea. But I was echoing on his track, and I've cleared it up as much as possible, but there's a few bits where I still leak in to his audio a little bit. So sorry about that, and hopefully it doesn't distract too much from the interview, which was a good one. So before I jump into that, just a few quick words from some sponsors. Today I'm joined by Venkat from Rockset. I was actually looking on my episode list, and we did speak 2.5 years ago. So it's been a while in tech terms. So I think we can begin again with what is Rockset? Let's start with that first.
Thanks for the opportunity. Pleasure to talk to you again. Rockset is a search and analytics database built for the cloud. Mm-hmm. So think about, as people, products and applications in the world gets more and more sophisticated, the limits of what applications you can build at the boundaries of a single node relational database, system of record, gets limiting. And if you want to build interactive search, interactive analytics, real-time customer-facing analytics, and more, if you want vector search, hybrid search, semantic search, kind of a search applications, or any kind of customer-facing analytical applications, that is where I think the traditional, relational stack or OLTP stack doesn't, meet your needs anymore. And you can build those kinds of powerful customer-facing and operational applications on top of Rockset.
The thing I'm trying to understand from looking at the website, you show the icons of quite a few traditional, some databases, but also kind of streaming and search systems like Kafka, Mongo, Postgres. So are you building on top of those, or are you saying you're replacing them? This converged index term, I couldn't quite understand. Is Rockset combining all of those, or is it replacing those?
So it can ingest data from all of those data sources. Okay. So if you think about these applications, right, like a customer-facing, let's say real-time analytics you're trying to build, or a customer-facing interactive search and reporting that you want to build. Let's say you're building a SaaS app, and you're building a recommendation engine. So it's a search problem more than any other information retrieval problem. And so if you want to build something like that, often your data is already that you want to build recommendations on, your product data, your user behavior data. It's basically already managed in a bunch of different systems. And so it typically falls into 3 categories. One is the streaming, data streaming technologies like Kafka and Ilk. A lot of behavior data, event data usually flows in that system. And the second set of data sources, I would call them as OLTP systems, where you have your user information, your orders, and like other system of record, things that you're keeping in your OLTP systems, and transactional databases and what have you. And the third category is systems from your batch systems, or data sets from your batch systems. It could be your lakehouse, your warehouse, just S3 type of cloud storage. So what Rockset allows you to do, it has built-in connectors with all 3 categories out of the box, because all these applications have to bring in the right data sets from more often than not, more than one of these types of systems. And so I want to combine, like, in order to build a recommendation data, let's take an example. I want behavioral data about what the user is doing right now in my website, in my e-commerce website. I want past order information about what the user actually has previously purchased. And I also want some offline batch generated recommendations and this and that is kind of like literally generic about, usually when people are looking at this product, they're also interested in that other product. And typically the recommendation engine that Rockset, people build on Rockset would combine these three. So you'd have one table in Rockset sourced from Kafka, another table in Rockset sourced from like in your MongoDB collection, and another table in Rockset sourced from, let's say, an S3 bucket. And now they just show up as three different tables. Rockset is a full feature SQL database. So you can join against them at query time, you can aggregate against them, and you can build very, very powerful interactive applications on top of it. Converge indexing, I would say, is a name of the storage format that we use internally. We use RocksDB as the storage engine. Prior to founding Rockset, I was at Facebook. I was managing online data infrastructure for all of Facebook, for all user-facing products. We built the systems that was a canonical store for Facebook. And RocksDB came out of my team. And so this was one of the things that we actually built to be the storage engine, the workhorse behind all of the data management systems. And it is the single most popular storage engine right now for all, distributed, modern data management systems. And Rockset also uses RocksDB as the storage engine behind the scenes. So converge indexing is almost like the storage format on how we take structured data, semi-structured data, and now even more vector embeddings and vector data, and translate that into keys and values in a RocksDB instance. And the algorithm on the storage format is what we call converge index. It has some interesting properties. It's mutable, so you can actually do real-time updates on that and still do it very efficiently. It is write optimized, and also you can now index the data and have like both, kind of a needle in a haystack type of a queries go really, really fast in that format, while also having like very good columnar kind of scan performance. So that's the storage format is what we call converge indexing. But really, I think every application in Rockset brings in data from one or two or more sources, and they bring in in real time. And so inserts and updates and deletes and other data coming into any of these data sources will get replicated to Rockset in real time, sub-second. And so you basically can very quickly onboard your data sets into Rockset in real time and use full feature SQL to build your applications very quickly.
And how much kind of auto magic is happening on that converging? You can potentially match potentially similar records, but it could be they're not. So how much of that is determined by the platform versus the rules you might configure, so you don't end up with connections that aren't there or duplicates or whatever it may be?
Very good question. I think there is a lot of need for, as the data comes in, people wanting to do transformations, maybe remove duplicates, remove poorly formatted data, enforce a particular schema. Yes. So what Rockset supports is Rockset doesn't do anything that you don't want to do out of the box. And what I mean by that is Rockset actually is a full feature SQL database, and we have SQL on both ends of the database. So even when you're bringing in data, you can use full feature SQL to define the transformations that you want to run in real time as the data comes in, even before it's stored in Rockset. So you could have a Kafka topic, let's say event stream, click logs, or whatever, coming through Kafka. And you can have a very simple SQL transformation. Say, I don't want to store the raw data. I want to simply group by these set of dimensions. And I want to, in the select class, I'll specify all the metrics that I want to maintain. And Rockset in real time, if for every new, incoming event that is coming through Kafka, it'll translate automatically and will maintain all those metrics across all those dimensions the way you define, as you described in the incoming SQL transformation, and only the transformed data will be stored in Rockset. And so you basically can still do real-time metrics tracking on raw event streams simply using SQL. So the flexibility on how much auto magic happens, there's no real magic. I think the magic comes from the fact that we can do SQL, like we have a SQL engine that works at the speed of real time, and then it is available on both ends of the spectrum. So it's really what you do with it as an application builder and application architect is more interesting than what Rockset does automagically. The converge index is interesting. The real kind of indexing, like how the data is organized in the storage formats of Rockset is interesting because out of the box, we are able to give very, very good query performance and search kind of query performance and analytical query performance on a wide spectrum of workloads out of the box because of the converged indexing data format. But that is really accelerating your data retrieval path, your query acceleration, your query performance gets better, but it's nothing to do with like how logically you're transforming the data or removing duplicates or any kind of that. That only happens when you go and use Rockset SQL as an ingest SQL transform and set it up whichever way makes sense for your application.
I've definitely seen RocksDB as a dependency in many projects, but does it also have a SQL interface, or is that something you've added on top?
RocksDB is an embedded key value store, and so RocksDB is a very important component of Rockset, but it's neither necessary nor sufficient. Rockset could be built on another storage engine too. Like we just chose RocksDB because it's very good and we're very familiar with it. But the SQL engine that we built in C++ is for these low latency, high concurrency kind of applications, is built from scratch and built for the cloud. The other really, really big differentiator I would say for Rockset is that it's really built for the cloud. And so it's a search and analytics database built for the cloud. And so one of the fundamental contributions we have had is what we call compute separation. And so Rockset not only have SQL on the ingest side and the query side, you can also have compute instances only doing data ingestion and aggregation and indexing and compactions and things like that. And you can have another compute instance doing query processing for your application. And they're completely isolated and independently scalable. No other real-time database that we are aware of has this. And so what that allows you to do is that in every real-time database, you have this problem where you have a flash flood of data. Suddenly your queries will time out. Your application will be sluggish. Or you have a flash flood of like burst of queries. A lot of people suddenly are logging in and using the queries. Now your data ingestion is going to get laggy, right? Like because all the compute is getting hijacked by the query processing. That problem is fundamentally solved and is eliminated from the Rockset architecture because you'll have one compute unit doing only ingestion. And that can independently auto-scale. We also have auto-scaling built in. And that will independently auto-scale based on how much data is coming in. And you have one or more compute units that you have for query processing for application A, application B. You can even have multi-tenant isolation. All of your, high-paying, like premium customers can use one compute instance and rest of the customers can use another instance. And you can kind of manage costs that way and performance that way and get full isolation and independent scaling with compute separation that is built in.
Sorry, this is potentially a dumb question, but I'm assuming it's a read-only. It's read-only.
No, very interesting question. Not quite. I think even stream. So Rockset is a fully immutable database, and so we have inserts and updates and deletes, and so it's very common. So I'll take an example. It's very common for people to replicate a CDC stream, right? So when you connect, let's say, a Mongo collection to Rockset or a Postgres table or a DynamoDB table to Rockset, inserts and updates and deletes to the source database will get in real time replicated to Rockset. So the indexes or the replica that you have in Rockset also needs to support inserts and updates and deletes. And so this is another really interesting property of the converged indexing. I was mentioning it in passing earlier, that it also supports mutability. It actually is very efficient. If you kind of like look at how the converged indexing format is built, to be able to mutate a portion of your records that you're keeping in Rockset, even though it's like could be semi-structured and deeply nested, it's still very, very efficient for you to kind of like mutate your data. So we basically natively support inserts, updates, and deletes. And so it's very important. So if you're only doing append only event streams like click log data, you're right. The data itself never gets modified. You're only keeping track of facts. But let's just say I want to aggregate. Let's say the raw stream is append only, but what I want to keep track of is a whole bunch of, let's say, counters across a whole bunch of dimensions. How many times have I seen this login attempts from this IP address every minute? Well, the counter is mutable. Every time there's a raw event data coming in, I have to do plus on, increment the counters for all the metrics that I'm keeping track of. So in that case, even a raw event stream that is append only, the minute aggregation happens in a data ingestion time becomes a stream that will mutate the metrics part of it at least. And so there's all these use cases where data mutation is extremely important, whether it is a CDC stream you're replicating or you're doing real-time aggregations on raw event streams. And for all of that is why we built Rockset with mutability in mind.
Yeah.
So it natively supports that.
I'm glad you had a good answer to that question, because that wasn't quite my question. My question is probably stupider, which was actually not the streaming sources, but something like Postgres or something like that. Could you ever, if you ever wanted to, write back to them from Rockset?
No, I think...
yeah, I mean, there was no reason to really, I suppose, but that's why it was a dumb question.
We haven't come across those use cases because typically you want like one system of record and one set of... Yeah. It's like kind of the CQRS pattern is like kind of very popular where you do all of your writes in one system and you try and that is optimized for availability. It's optimized for not losing your data and point in time recovery. And then you replicate that in real time, and Rockset can replicate data sub 100 millisecond in terms of data lags. And so it instantaneously gets into these other read optimized systems that can fast follow your system of record and now power search and analytics and all sorts of really advanced parts of your application stack. And so you can have your cake and eat it too. And I think that division of it's almost an architectural pattern that I think is very popular, because it's like the responsibilities are very clear and what the OLTP system of record is optimized for. Just do CRUD and key value lookups and mutations there, and that is your system of record. And then just attach Rockset to the hip and real time replication, real time ingestion will basically allow you to also now power very sophisticated search and analytical and real time analytics and all sorts of other kinds of workloads on top of that.
I'm glad. I think your first answer was better because the second question was a bit stupid for me. But I don't know. It's just something that came into my head. So we spoke 2.5 years ago. What's new since then? I can see lurking on the right-hand side of the diagram at the top of the web page, of course, as everybody else has now, OpenAI and Hugging Face. But maybe let's go back a bit first, because that won't have been in the past 2.5 years. That's probably in the past half year. So what else have you added it's maybe since we last spoke that you think is a major thing that's worth mentioning? And then we'll come to the AI stuff.
We've added is a lot of customers. So we have hundreds of customers, building very, very sophisticated customer-facing applications, recommendation engines, like insurance, companies and fintech companies fighting fraud in real time, to lots of companies, managing risk and other, really important business metrics in real time, to customer facing applications. We have like one of the fastest growing marketplaces in the US, powering their For You recommendation feed that you get when you log into their e-commerce website is 100% powered by Rockset. So yeah, number one, I would say what has happened is like hundreds and hundreds of like new applications or mission critical customer facing applications are now powered by Rockset. Number two, I would say the compute separation piece that I talked about has been, I would say it's a tectonic shift in terms of how real-time databases should be built in the cloud. It's a leapfrog moment for that whole space, because flash flood of data, kind of like making your queries time out, and a burst of queries making your application laggy in terms of data freshness has been true since the beginning of real-time databases in every shape or form. And I would say for the first time, being built for the cloud, we are able to exploit, and build an architecture that not only has compute storage separation, which you should demand from every cloud database these days, but we also have compute separation. So even though there is one compute unit doing ingestion and another compute unit doing query processing, the query within single-digit milliseconds, new data coming in, even though it's getting processed only by this compute unit, will still be reflecting in your queries by completely independent and isolated compute engines doing query processing. So by basically compute separation while still preserving real time on one copy of your data, I think has been I would say, a complete game changer on how quickly application teams and product teams are able to move on their roadmap. Because you can go and test in production. You will have one compute instance doing all of your production queries. Now you spin up another compute instance on the same production data. You can do whatever with it in one. It's completely isolated. So you have, nothing really can go wrong, as long as you don't touch your production compute units that is doing either ingestion or query processing, which could be two independent ones. So that, I think compute separation has been like a very, very big, came out of like so much work we've done over the last 2 years. And the culmination of that is this really amazing architecture that I would say sets a bar for what a real-time database in the cloud should look like, and especially search and analytics ones, because people end up building customer-facing applications and mission-critical applications on that. And last but not least, I would say I have to talk about vector database. So Rockset as a vector database, at the end of the day, if you take all these AI applications and vector embeddings coming, and getting extracted out of them, what you really have is an indexing problem. That is the only thing we know. Like, we are always, from day one, a real-time indexing database. And that is why we're good at search and analytics, and we're built for the cloud. And so the robustness, the scalability, our high performance indexing architecture using converged index, the word, it's in the name, to compute separation, and all of that comes in extremely handy to power all these kind of like vector search and Rockset as a vector database. So now we have native support for, also indexing vector embeddings, and build all these approximate nearest neighbor AN and similarity search indexes on them. And at query time, simply using SQL, you can now combine vector data and metadata, as like multiple different columns in the same table. And you can do ANN queries, you can do KNN queries as, simply using a where clause in a SQL query.
So this is the leading towards the, I guess, more recent integrations with OpenAI and Hugging Face. It's more the model querying.
Yeah. Exactly. So the models will turn like your, whatever data that you have into a bunch of embeddings, which are basically vectors. You can load them into Rockset, and then you can also have metadata alongside it. And we have JetBlue, we have many big customers in production using Rockset as a vector database. We had a conference called a community conference called Index, where they came and talked about their use case, and it's all available if you search for it. In the Index conference, or go to rockset.com, and there are links to the videos of those talks. It's really fascinating how important hybrid search is, and also real-time updates on your vector embeddings also. And so essentially with both real-time updates and hybrid searches is as simple as a SQL where clause. And Rockset as a vector database is a very, very, it's a third big thing that I would say we have launched.
I think I'm still trying to understand quite how that would work with that, the model data, but because it's a little, the source information is potentially a little more abstract than streaming data or.
So I would say typically like RAG is a very common model on how it works with LLMs, right? So say you're building a chatbot. And you're you're asking a specific question. And what happens is that every prompt that you're asking your LLM will turn into a similarity search.
Yeah. And then you can actually pull in similar data from other sources.
And what you do is you feed that similarity, the result of the similarity search, into the LLM as context, and then prompt it to say, hey, now that I've given you all of this stuff, what do you think the answer to this question is? Yeah, but then the user doesn't see all of the similarity search and RAG kind of like, augmentation. So it just feels magical. It's like, it's like, what is my Wi-Fi password? I couldn't have built an LLM that's going to give you your Wi-Fi password for your company, for your corporation.
But if you have it in a database, you can. Yeah.
Done. Taken all of your body of text documents and turn them into vectors. And you do a similarity search on Wi-Fi password, blah, 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 and go back to your corpus of documents, and you're going to get all of the relevant documents and say almost like copy paste that, into your LLM prompt. And that is what that is why RAG is so popular. And every RAG needs a vector database on the other side, and Rockset is a great one for that.
It kind of superpowers that growing concept of like training an LLM on your own data, but most of the time that's people talking about it on a much smaller scale. This is kind of doing it on a bigger and real-time scale. So the even in vector database, right? For example,
you're building these ANN indexes, like multi-tenancy is a very important piece. I'll pick like why do people can use other vector databases? It's really important that you build these approximate nearest neighbor kind of indexes, similarity indexes, but you don't want to accidentally leak, right? So if you basically have, let's say, a SaaS application that is multi-tenant, you don't want vectors from one tenant to bleed or be used to build these indexes and centroids and k-means clustering on whatever you're doing to try to index all of that from one tenant to another tenant. And so you kind of want even multi-tenancy support natively built in, and this is what Rockset has. And so Rockset is a vector database to power these kinds of multi-tenant customer-facing applications is, again, like very, very, is what we do. And this is what we've been doing for non-vector data since the beginning of time, I would say, of the company. And now we can also do it for vector data. So now you can combine applications with vector and other metadata and build very, very powerful applications, whether it is AI, real-time analytics, search, we have you covered.
So final question, 2.5 years. What do you think is coming next as data sources, as vector data that you predict you will be, or you might need to add as sources for customers in the coming years?
Oh, very good question. I think in terms of data sources, I don't expect us to. The ecosystem is getting really good. When we started the company, like there weren't a lot of real-time data connector providers and this and that. A lot of SaaS applications or other places where your data would get stuck. It'll get stuck and only batch export was possible. So I think the ecosystem has come a really long way to be able to incrementally, the CDC streams, like, technologies like Debezium, and so much has happened in the last, let's say, 2-3 years. What we're really figuring out is we have like the core set of connectors where, we have the most important and the most popular data streaming, like, kind of connectors, most popular OLTP databases, and most popular kind of like cloud storage and lakehouse warehouse connectors. So I don't expect us to add a lot of connectors. What I expect us to do is, make more on the query processing side, right? Like what kind of indexes can you build? What kind of data types can you support? How sophisticated can your applications can become? And that is where I think like we're going to be, we're just scratching the surface with this whole, ANN and KNN. Multi-tenancy is one important thing that we're uncovering now. I think there is a lot more to be built there. So I think the biggest thing that I would say in that I would come close to prediction is that chatbot, LLMs, and like, OpenAI's ChatGPT has kind of like given people this impression that there are traditional applications and then there are these AI applications that are kind of chatbot-esque. I think what we are seeing, and I think this is what I think where everything is going, is that AI is going to get infused in every single application.
Yeah, and that's actually the really useful applications of it. The ones that is kind of a toy examples, it's like, well, that's fun, but it's not actually that useful. Yeah.
And I'll give you examples where, every recommendation engine is going to get infused with AI. It's not going to be it's not useful to tell me that this song is closest to this other song. Remember my previous skip history, remember my listening history, and come up with a recommendation that I will not skip. You know what I mean? So to me, every application is going to infuse with AI. And so when you look at that, what is important? Well, I need to do hybrid searches across vector data and non-vector data. I need to do real-time updates across vector data and non-vector data, right? And I want compute separation and scalability. I need multi-tenancy. And so what is really going to happen is that this whole thing is, is this like this fad that there are AI apps that we need to scale and build and all of that. I think is going to be completely upended and say every application is an AI application now, because everything needs to get enhanced with things that my application stack couldn't do before. But it is not instead of, it's in addition, right? Like I think that is the biggest trend that we're seeing.
Well, we'll see what the trend is in a couple of years, and maybe it will still be with us, or maybe it was something else in addition to that. Cool. Now, you don't have any kind of like self-serve free tier, but you do have a $300 credit like trial if people are interested in experimenting.
We do have a small free forever tier if you just want to play with it for a hobby or something like that. You can have up to like 2 gigabytes of data. So it's like, it's enough to for a hobby.
Oh, yes, you're right. Including a free. Oh, yeah, you're right. Actually,
yes, we do. But we do have a free.
The wording is, okay. Yeah.
We do have a free trial for others with a larger data set to get started. Yep. Self-service, it's available. We have a lot of customers that just come connect their DynamoDB table or MongoDB collection just to get a search and analytics kind of like APIs to be powered out of Rockset instead of the core OLTP that cannot do search and analytics very well. Yep. And that's a very, very common and popular integration that we have. And you can go and check out rockset.com and just sign up for a trial if you're interested.
And that was my interview with Venkat from Rockset. Hopefully those audio issues weren't too distracting. Now, the main news from me this episode is going to be the main news I will keep promoting for a little bit. Is that I have a book out. The first of 3 books for the year, actually. It's on technical writing, documentation, etc., aimed primarily at software developers, published by Pact Publishing. Seems to be doing reasonably well so far. And you can find more about that at chrischinchilla.com/books. That aside, I have also started writing for the Next Web again, and I have an article up there on the state of open source in Europe, which was basically a summation of my experiences at FOSDEM and the state of OpenCon back in February. And I'm also working on a roundup of KubeCon for the Next Web too. So you can also find links to that in the show notes. That aside, I have one small video, which was messing around with a little kind of slightly entertaining mobile application called Dreamface, where you can animate pictures of yourself and do sorts of weird things like that. Not something I normally cover, but I thought I'd give it a try. And that's up on my YouTube channel. I'll also include the links for that too. I'll have more for you next week in a news show where I think I will be on the road. So who knows what microphone I'll take with me. But until then, you can find more about me at chrischinchilla.com. As always, thank you very much for joining me and take care, everybody. I hope you enjoyed the show. Find out more about me at chrischinchilla.com, where you can find show notes, sign up for my newsletter, and find all of my writing, games, work, and video links. There's also details on how to get in touch with me. And if you want to get even closer to what I do, join my Discord server for behind-the-scenes discussions and helping me produce my shows and work.